Hello, my name is Shane Philhower, and I'd like to share with you my project for the Bioenergy and Sustainability School Supervised Study from spring 2016. This is our site-specific self-contained rainwater harvester. It's site-specific in the fact that we designed it per Gainesville precipitation rates. We gathered our data both on-site with rain gauges, but then also used an average data collected from the Gainesville Regional Airport. And we're using the minimum monthly averages with a standard material roof, 8 by 12, to determine how much water we can collect and what size vessels we may need to store it. At 120 square feet and approximately 2 inches of rainfall per minimum monthly, we went with 50-gallon rain barrels at 100 gallon, two of them at 100-gallon capacity to fulfill the approximate 120-gallon potential. Then we had to determine what to do with that water. Being a smaller rainwater harvester and collecting at the minimum around 120 gallons, we wanted to have something that would still be useful but not outstretching or using too much of our storage. And we thought of a hygiene station, particularly in the developing parts of the world where sanitation is limited. Having the means to create a communal latrine and a communal hygiene station to wash hands afterwards could be a great public health service. One of the benefits to doing research and supervised study here at the Bioenergy and Sustainability School is that your projects stay here at the school after. Right now, I'm glad that this has become the centerpiece of the best garden. Another benefit is that your work or my work can then become a platform for additional research, ideas, and discovery. Though this was initially designed for a hand wash station, we are now looking at how to utilize the water gained during the maximum times a year when where we had the potential to collect 300 to 400 gallons in a month. We're trying to determine ways to irrigate parts of the garden, looking at plant capacities for evapotranspiration, how we may want to space those plants, how the frequency that we may want to water. One of the difficulties with designing systems with rainwater harvesting is when it's raining, you often don't have to water. However, to optimize the water that we can collect, we have to discharge the water from our vessels so they can refill during those times to get the most of that 300 or 400 gallons. But having a smaller unit, it is also scalable. So when we do find that garden and plant selection that this can work ideally for, we can look around and find other roofs or other materials to efficiently irrigate the rest of the garden. I thoroughly enjoy my time as a student here at the Bioenergy and Sustainability School, and I highly recommend this program and this area of study for anyone who's interested. Thank you.